Hello Internet. Today we have this weird looking Asus Strix 3090.
It's 3080, you numbnuts!
Customer said corrosion, so let's take it apart and see what's corroded. Interesting thing to note when I removed the cooler was this thermal pad that somehow was not contacting the memory chip all the way. Not sure what happened here. And another interesting thing is the core itself. Since this is a 10GB version, one of the memory channels is disabled. What's interesting about that is that the channel that's disabled is B. Usually it's D, but who cares? It doesn't really change anything, it just makes this GPU more unique. That's all. As for the corrosion, I don't see any, except when I looked into the HDMI and DisplayPort. But I doubt that's causing any issues. In any case, after checking for resistances in the key areas and I didn't find anything suspicious, I powered the board and it looks like we're having issues with power. Board is pulling less than half an amp, which means some voltage is missing and we gotta find which one. We have 12 everywhere, 5, 1.8, nothing on the core, memory or PEX, and that's basically the problem. Okay, so first let's check if the power controller is enabled by probing the enable signal with resistance reading. There is no short on that pin, but once the board is powered, that pin becomes low and we're reading low resistance, effectively killing any voltage that could be on that pin otherwise. The enable signal is the output, meaning something outside of the controller is pulling it low. Usually some kind of a dual NPN transistor or a logic chip, so I'll start tracing the signal back from the controller through this 0 ohm resistor and into this logical U-gate output pin number 4, which reads those very same 43 ohms. In order for this U-gate to function correctly, it has to have 3 voltages. VCC, which has 3.3 volt, and the 2 inputs. First reads 0 and the second reads roughly 1.8. So basically we're missing first input, which comes from the identical chip on the left from here. So let's check that logic and see what's going on. This chip first input is 0.8, which is low, and the second input is 3.3. And because the first input is not high enough, this U-gate will pull the output low, consequently pulling one of the inputs low for this U-gate and then back into the controller, effectively disabling it. But why? Why such a low voltage on this input? Let's trace the first input backwards and land on the output of yet another U-gate. Now let's repeat the same test and see what we're missing. VCC is good, first input is good, and second input is good. But the output, which is connected to our previous U-gate input number 1, is the very same 0.8 volt as we've seen before. So theoretically, this U-gate is not generating proper output voltage, and one way to find out is to replace it and see what changes. The U-gate is replaced, no short anywhere, so once we power the board, I get 3.3 volt. And we also have voltages everywhere, and consequently, once the card is powered by the motherboard, it posted, and I think we have a fix. All that's left now is to put new thermal pads, new paste, and all of that was already done at this point, so hopefully this video was educating, maybe entertaining at times, and if it was, please hit me with a like, a comment, and subscribe for more repairs. Thank you, and goodbye.